Alright guys, just a quick overview about the number system, and what do we got here? First off, we have what I like to call the real numbers. Well, I don't like to call them that. That's what they're called. And let's see what I got here. So, real numbers include any number that can be expressed as a decimal. So pretty much anything you probably have ever seen or can think of is a real number, so anything. Okay, so the real numbers are a real broad spectrum of numbers. So if we look here, the real numbers are, and they're anything you think of: fractions, decimals, anything. There are some things that aren't real numbers, but they're called imaginary numbers actually, and they're not really part of anything you'll do in high school. So you're pretty good with it. So any number you can think of, positive, negative, fraction, decimal, anything is a real number. And you notice here that we split up next into rational and irrational numbers. The difference between those are, so real numbers are anything, and then they're split into rational and irrational. The key to this is a rational number is a number that can be expressed as a fraction. So 1/4, 7/9, 13 over negative 144, anything like that, anything you can put as a fraction is a rational number. An irrational number is something that can't be expressed as a fraction. So we'll get to those in a second. They do exist, so they might be hard to think about, but any sort of fraction is a rational number. So examples of rational numbers, any decimal, so if you have a decimal and it ends like 0.125 ends here, or it repeats like 0.333. So if you grab your calculator, or you've probably done this before, if you go 1 divided by 3 and throw it in the calculator, you get 0.333333, and the 3's repeat, okay? So anything as a fraction will repeat as a decimal, or end as a decimal. Okay, so the things that end are like 0.5. 1/2 is 0.5. 1/4 is 0.25. 1/8 is 0.125. They end, okay? So any fraction will either end or repeat. If you want to have some fun, see if you can figure out the pattern in 1/7, 1/7, 2/7, and all that sort of thing. We can talk about that in class. It's actually very neat. So that's a rational number. The other thing I want to mention is any whole number can be expressed as a fraction. So if I have the number 7, it's equivalent to 7 over 1, right? So anything like that, or negative 7 would be negative 7 over 1. So any whole number, any number that we would call a whole number, like 5, 2, 32, whatever, is going to be also a rational number. So we have that. Irrational numbers are numbers that do not repeat, okay? So things like this, 3.145, that number there, pi, right? The root of prime numbers, so the root of 3, the root of 2, all those numbers like root of 7. If you throw root of 7 into a calculator, you won't see any repetition. And even if you had a giant calculator, it would not repeat. Same with pi, obviously, right? Pi keeps going and changing and changing and changing, and there's no pattern to pi, okay? So those are called irrational numbers. If we want to look more at rational numbers, back to where we were earlier, they can be ripped into pieces. I don't know, ripped or put into pieces also. And they can be called, rational numbers can be called, include what we call the natural numbers. So the natural numbers are numbers that are, those are the numbers you learn to count. So these are your kindergarten numbers almost, right? So your natural numbers are 1, 2, 3, 4, 5, right? All those numbers like that, okay? As a math teacher, when you teach your kid how to count, you go, it can be very confusing because I say, what is after 4? And then they go 7, and you go, well, technically 7 is after 4, but it's just not the next integer after 4, okay? So that was always a bit of a challenge, but we get over it, okay? So those are natural numbers. A whole number is exact same, except it includes 0, okay? So that's a little tricky one there. Natural is the numbers you learn to count with. Whole numbers is 0, 1, 2, all the way up, okay? So they're your whole numbers, but they include 0. Integers, I know you've done this before. Integers are all the natural numbers, all the whole numbers, and also the negative numbers. So integers include the negative numbers, okay? So, but they're in layman's terms, okay? In normal speak, they are whole numbers that can be positive or negative, okay? So they are not parts of numbers, okay? So 5 so we're looking at a number now. 5, it's a real number. Okay. Everything is. Okay. It's also rational. Okay, because it can be a fraction. It's a natural number, and it's also a whole number. And it's an integer, so it's everything. Okay. -2 would be everything we just said. Okay. Except it's not natural and it's not whole. Because it's negative, it's real and it's rational. Okay, so -2 is real because it's anything we thought of. You can picture. Okay, you can write as a decimal, -2, or -2.0, same thing. It's rational because it's a fraction. It's -2/1. It's integer because it's -2. I know we would say it's a whole number, like in normal talk, we would say it's a whole number, right? It's -2 degrees and then -3 degrees. But if we go back to what we define as a whole number, okay? So we go back to whole numbers. Where were we with whole numbers here? Whole numbers, the definition of what the math folk call a whole number are positive numbers, starting at 0, okay? And then we have the last example. Let's go to this one. Nope, this one here. 0.33, okay? It's a real number. And it's 0.33 isn't, but if it was 0.33 repeating, which is probably what this is supposed to be, it's also a fraction, so it would also be a rational number. Okay. What other type of number is it? Well, it's. Oh, what'd you say? It's real. Is it any other type of number? Is it a natural number? Nope. Is it a whole number? Nope. Is it an integer? Nope. Okay, so we have real. Is it rational or irrational? Is it a fraction or not? And is it a whole number, an integer, or a natural number and or? Okay, so 0.666 repeating. It's not going to be natural. It's not going to be whole. It's not going to be integer. Those are numbers, the counting numbers, either positive or negative, or depending on our definition, right? It's rational for sure. Okay, because it's 2/3 is 0.666 repeating. Okay, you get the repetition. So it's not irrational, and then it's real. Okay, so all these numbers are real. Okay, and then we just have to go from there. Okay, 0. So 0 is a tricky one. Okay, it's real. It is rational. It'd be 0/1 is 0. Okay, so it's not irrational. It's rational. Is it an integer? Is it a natural number? Is it a whole number? Well, let's go back to our definitions here. Okay, so if we go back to our definitions, it is not a natural number. It is whole, and it is an integer. Okay, so that's just gonna be careful with that one. -13. -13 is going to be an integer. It's not whole and it's not natural. So these are just definitions, right? They do matter in the world of math. Not so much now, but they do matter later. So it's an integer, but it's not natural. It's not whole. And because it's -13, it's a fraction, right? Any whole number, not whole. I should be careful with that, right? I think I've misused the word whole. Any integer is going to be a rational number also. Okay, and then it's not irrational, and then it must be a real number. And that's it. Okay.